So we want to find x for both triangles. So remember, when we're doing trigonometry, label your sides, opposite, adjacent, and hypotenuse, right? So this one, we've got adjacent over hypotenuse. Here, we've got the adjacent and the hypotenuse, so we better be using cosine. So for this first one, the cosine of 30 degrees is adjacent over hypotenuse. Cross multiply and divide. When you do, you're going to end up with 12 over the cosine of 30. And that's what you're going to plug into your calculator. Double check the screen, make sure in the lower right-hand corner it says DEG. Otherwise, you will not get the correct answer. So here I'm doing 12 divided by cosine of 30. I plug that into the calculator, and what I get is 13.856. It keeps on going, but remember, if you're not told, if you're not specifically told, round to 4 decimal places when it comes to this stuff, okay? So for the first one, we end up with 13.8564. Is that what you got that? Okay, make sure you're doing this like this. When you write it out, cosine equals, in this case, it's adjacent is 12, hypotenuse is x. Cosine equals 12 over x. Cross multiply and divide, make sure you get this. When the x is in the denominator, it's going to be number over trig. If the x is in the numerator, it'll be backwards. It'll be trig over number, right? Or trig times number. Yeah. All right. Yeah, we good? We good out here in internet land? Cool. All right. So let me make some room here. All right, now for problem number 2. Again, label your sides so that you get what you're supposed to get. Here we've got the opposite and the hypotenuse. So this time we're looking at sine, right? So this time we've got sine of 15 degrees equals opposite over hypotenuse, 15 over x. So once again, cross multiply and divide, right? You better get x equals 15 over sine of 15. And then you do that in your calculator. Yeah, okay. We end up with a much bigger number, right? We get 57.9555. Again, that's rounded. It keeps on going 4958. That's what it keeps on going in my calculator. But that's what we end up with. That's the length of this side. 57.9555, and it keeps on going, right? These keep on going. All right, so there we have a little bit of a review of some basic trigonometry. We're going to be using this today, and believe it or not, using this makes life like 50 times easier. I see skeptical looks. I promise I will validate your concerns in a second. So, last week, we went and we struggled sometimes to figure out the area of a regular polygon, right? Especially with when they were just giving us any old thing, and we had to like do a lot of legwork to figure everything out. Today, I'm going to simplify the process for you with trigonometry. Trigonometry is going to end up being much simpler to do because it's not going to involve like doing different things every time. If you follow the method that I give you, and I'll tell you this, again, the book basically tries to double down on that whole apothem times perimeter thing, and trying to do a problem that way is so wild, it is almost funny. If you use the tutorials on the Math Excel, it is going to take you on this incredible, terrible journey trying to use trigonometry to find the apothem, trying to use trigonometry to find the perimeter. If you do it my way, and this is actually doing it with like the tools that they give you in this section, it's going to be a problem. Trust me on this one. All right, so like I said, if you go through and you do it my way, you're going to have a way that is 1, the same way every time, 2, a lot less work, and 3, still using everything that the book gives you. I don't understand why the book doesn't do it this way. They're really, really, really just dead set on that 1/2 AP formula, and I don't know why, because what I'm about to show you is so much easier. So a little bit of background stuff. When we, and again, this comes from this very section, and they're not going to use this, and I don't know why. There's another way to find the area of a triangle. If you don't have the base and the height, if you've got 2 sides and the angle in between, right? They're talking about side angle side, right? If you have 2 sides with the angle in the middle, you can still find the area. The formula they give is right here, 1/2 times the 2 sides times the sine of the angle in the middle. This formula right here, 1/2 BC sine of A. And we're going to use this today. We're going to use this to make our life 50 times easier. All right? Now, again, I don't like just say, hey, here's a formula. This is the whole reason why, if we look, this is that very same triangle. Here's the base, here's the height, right? The formula for the area of a triangle, as we know it, is 1/2 base times height, right? So all we're going to do is we're going to say, all right, how can we take this height and rewrite it in terms of that side? And if we use sine, we can do that. Because the sine of this angle A is equal to the height divided by this side C over here, right? Opposite over hypotenuse, right? So all we're going to do is we're going to solve for h so that we can throw it into our formula, 1/2 base times height. So h is going to be replaced by c times the sine of A. And that's it. Now we have that formula that we're looking for. How is this going to be helpful to us? If we think back to last week when I first introduced this, one of the things that I did in the beginning was showed you how to find one of those central angles for a regular polygon, right? You know, you just say, all right, well, I know that all the way around is 360. How many sides are there? There's 5 sides. Oh, just divide by 5. That's the central angle, right? And I also showed you how to take that triangle, cut it in half, so you can find that half angle. By doing that, we now have all the things that we need to be able to find the area of one of these triangles using this formula instead. All right? So let's do a couple practice problems with these triangles, and then we'll dive into how to actually easily find the area of a regular polygon using this trig stuff. Okay? So here's our first one. Remember, all we're going to do so BC times the sine of the angle in between, right? So I'm just going to do that. 1/2. Well, what are the two sides? 12 and 21, right? Times the sine of what's the angle? 48 degrees. And now all I have to do is 0.5 times 12 times 21 times sine of 48. Ta-da! My answer here is 93.6362. They don't tell us how to round, so we round to 4 decimal places. Our units here are centimeters. So centimeters squared is the area of this triangle. See how quick that was? Not difficult. We're going to have to be given all the things, so we can just plug it into the formula. So go ahead, give this one a try. Same idea, just different numbers, right? You want the area of the triangle. Now they specifically tell you how to round in this one. They say round to the nearest square inch, so the nearest whole number. Alrighty. So once again, don't think too hard about this. You got the two sides and the angle in between. Throw them in. Right, and then put that in your calculator, and it says round your answer to the nearest square inch. It comes out to be 44 point something. We want to the nearest square inch. Right? So the nearest whole number, it was 44.7. That 7 rounds up, and so we end up with 45. And what's our units? Inches. Where? Good. Here. What I want to tell you is, again, now I'm jumping off the pier because the book doesn't do it this way. But I made my own little slide here. So if we have a regular figure, remember that these radii are all the same, right? One more reason why this is like 10 times easier, because if we know one of these, we're already good to go. And then we can just say, all right, well, what's the angle? And then we can just do 1/2 times the radius times the sine of the angle. So all we have to do is figure out what the radius is, and then we're immediately good to go. So one triangle is 1/2 times the radius squared times the sine of the angle. That's one triangle. And then how many triangles are there here? Well, from there, it's just count how many triangles, multiply by that many. And then you're immediately good, right? So let's start out with where they give you the radius directly, and then we can come up with the answer. And then the last one is going to be, hey, they gave you something else, like a side. All right? So, talking about a stop sign. A regular octagon. And they measure the radius to be 16.2 inches. Well, okay. First of all, octagon. I apologize for my terrible drawing, but here we go. How many triangles are there in this octagon? 8, right? You go from the center. We make the little umbrella corp symbol, right? See, I know. All right. We know that the radius is 16.2. All we need to do is figure out what that middle angle is in between, right? Well, if it's 360 all the way around, we just divide by 8. What's 360 divided by 8? Yeah, 45, right? Well, now don't we have all the things we need? 1/2 times the radius squared times the sine of 45. That's 1. That gives us 92 point something, right? Now, all I need to do from here is multiply by how many triangles there are. There's 8 of them, right? That's what we counted. 1, 2, 3, 4, 5, 6, 7, 8. So just take this and times 8. Do it in your calculator because ain't nobody got time for this. And then they say to the nearest square inch, the nearest unit, the nearest whole number. This 2 rounds down, so we're left with 742, and then our units are inches squared. Y'all see how much easier that was? And the best part is, if you've got the radius, it doesn't matter how many sides there are. You can just do it. The only thing that changes is what's the angle in the middle, right? 360 divided by whatever the angle in the middle is. That's the only thing that you have to check every time for a problem like this. So let's do another problem. We're talking about a tabletop has the shape of a regular decagon. Decagon meaning how many sides? 10 sides. Very good. With a radius of 9.5 inches. What we want to know is what's the area of the tabletop. And they want it rounded to the nearest square inch. All right, so let's identify our R. Let's identify our angle. Well, they give us the radius right here is 9.5. And then the angle, well, it's a decagon. I'm not going to try and draw that. That's beyond me as a human being. But there's 10 sides. So we know that each of those middle angles is 36 degrees, right? So all we have to do, here I'll draw one triangle. All we have to do, here's our radius, there's our angle. I'm only leaving this calculator over here. Why not just put it in my pocket? So we got 0.5 times 9.5 squared times the sine of 36 gives us 26.52380,951. And there's 10 triangles. So that's what we get. It's important to wait till the end to round because you want to get the most accurate answer possible. So we get 265. It's our final answer, and our units are square inches. Pretty simple. Still pretty easy, yeah? See, I'm telling you. Now remember how hard it was to do like a hexagon or a triangle or a square? Now the only difference between what we just did and what we did before is now we just take 360, divide it by 4, and then when we find the area, we multiply it by 4 for like a square, or divide by 3, multiply by 3 for the triangle, or whatever, right? Same exact process. It doesn't matter how many sides there are. It could be 50 sides, 121 sides, however many sides. The problem doesn't get harder. It's always the exact same problem now. Think about what a relief that is. Now we only have to remember how to do one thing all the time. And I'm going to give you a hint. If you struggled on, what was it, like assignment number 13 or whatever, when it was from last week, when we did this without trigonometry, if you struggled on that, guess what you can now go back and do? This. So much easier, ain't it? Okay. So the only question becomes now, hey, okay, they gave us the radius each time. What if they give us something else? Still easy, because all we have to do is one little thing, right? Just like what we did in the bell ringer, we can find the radius really easily. All we have to do is break this down. We know that each of these sides is 10, right? So if each of these sides is 10, this little right triangle thing here, we want to find this. We have this little piece, right? Because it splits them in half, right? So each of those little pieces are 5. You know, the whole thing's 10, 5 and 5, right? So let me figure out what this angle is, and then we can figure out what the radius is really easily with trig. So look, it's a 9-sided figure, right? So the big angle is 40. That means that the angle that we actually need to work with for a minute while we do our trigonometry is half of that, right? We just like we do with the side, we split it in half. So we got a 20-degree angle. Why is it 20? Because this whole thing is 40. And notice we only want this half. So we just want half of that angle. We want 20. And now let's orient this so that it works really well. That's our radius that we're trying to find. This piece is 5. Now we're back to what we did in the bell ringer, right? So here, opposite hypotenuse, we're using sine. Cross multiply and divide, right? There's a method to my madness, I promise. See, all we have to do now is take what we did in the bell ringer, do it at the beginning of this problem, and then it's all downhill from there, right? So whatever that is. That's your radius, 14.6 something. Now, the one thing that's slightly inconvenient is that sometimes we're going to have a big old decimal that we have to write a couple times, right? But I'm telling you, doing this is still 50 billion times easier than what the book was going to try and get us to do. Because they were going to try and be like, okay, well, you can find the apothem. Well, that's just with the cosine. So that we're already doing that, right? And then we got to find the length of the side, find the perimeter. What if they give you the radius? They were going to try and make you find both the apothem and the side. Do 2 sets of trig. Ain't nobody got time for that, right? No. So I'm telling you, making it your goal to figure out what the radius is, at worst, there's going to be one point in time where you have to get a little decimal thingy to carry around. At worst, right? This is now literally the worst case scenario that they could possibly have. All right, so you go through (14.619022), and that's the worst part of it. See, now we've done that. All our pre-work is done. We can now take this part, scooch it up down here, and do our problem. So we know our angle is 40, the big angle, right? That's 40. We know our radius now is this 14 point something. Still the same problem. It's just this number is now slightly uglier. Not a lot uglier, just a little bit. Just a couple extra button pushes. And to be honest, if you've already got that number saved in the calculator, you can just work around it. So I'm going to square it, divide by 2, multiply by sine of 40. Didn't even have to do any extra typing, right? That's the beauty of having this calculator in front of you. And then there's 10 of these, right? Nonagon, I apologize. There's 9 of these. So you just take the number that you've got, this that's what you get when you plug that in the calculator, right? This thing. So now we just multiply that by 9. Again, I haven't done anything but put it in the calculator. Voila. And again, they don't tell us about how to round it, so we round to 4, right? 4 decimal places when they don't tell us otherwise. That's a 1, so this goes away. So we got 618.1824, and my units are centimeters squared. All right, so to review, let's go over this. Let's talk about sort of the general process, right? If you can do what we have here, then you have no problems at all. Thing number 1, identify, do you have the radius or not? If you do have the radius, yes, just go straight on. If you don't have the radius, you need to find it. The way we find it is using trigonometry. We find this little half of a pizza slice here in the big figure, pull it out, label all the sides so you can figure out what the radius is. Now, if they give you the side, then we're talking about ending up using sine, right? Sometimes they might give you the apothem, in which case you'd end up using cosine, right? That's why I gave you 1 sine and 1 cosine in the bell ringer, because either you're going to have to do sine if they give you a side, Hey, they sound the same, right? Sine and side. Big brain. Cosine is when they give you the apothem. And then from there, it's just a matter of finding what the radius is, right? Like we did here. Once we do that, we have the radius, we move on. 1/2 times the radius squared times the sine of the big angle in the middle, right? And then multiplied by the number of sides. Always the same process. Always the same process. There might be a little detour right here if you need to find the radius, but once you have that radius, it's always the exact same thing. And I'm telling you, what we just did, 50 billion times easier than what the book is trying to get us to do. Every time. All right? So I want you to try this one out. Same process as what we literally just did. Find the radius first, then plug it into the 1/2 r squared sine of the angle formula, multiplied by how many triangles there are, and you're done. So make sure that this is something that you can do once I make it big enough for everybody to see. So they want to know the area of a regular pentagon. How many sides does a pentagon have? 5. Very good. 4 inches on every side. And they want you to round your answer to the nearest square inch. All right. Let's do this. So we want to know the angle of the area of a regular pentagon. So it does help sometimes if you draw. Yours is going to be much better than mine 100% of the time. I can't draw. It helps if you draw it out like this so that you can see it a little bit better in your mind. Because the human brain is usually running at 50% at best. Take a minute and draw it out so that you're not trying to do it all in your head. Because I don't know about you, but I only have like 3 good brain cells left. And this is too much for those. So what I want to do, since I know that each of these sides is 4, I need to find the radius. I need to find this guy over here, right? So we need to do a couple things. First, we need to use trig to figure out x. So we know if the whole side is 4, this half side is just going to be 2, right? We also need to know what this little angle up in here is. Now, we got 5 of these. So one of these pizza slice angles up here is 72 degrees, right? But we don't want the pizza slice angle. We want the one that's half of that, right? So we want this to be 36 here, right? Now I've got everything I need. Let's bust this out, bring it up here so that we can do our work. Now, once again, always take the time to label your sides so you know which is which. SOHCAHTOA, so that you keep that in your mind, in your brain. We got the O, we got the H, so we're using sine. Opposite over hypotenuse, like that, right? Cross multiply and divide. And that gives us whatever it is that that comes out to. 2 divided by the sine of 36. Probably much bigger than 2. Well, relatively speaking. So we got that for our radius. This is the radius, what we just found. So now, let's go back and do the problem. We found the radius, now we can actually do the problem. at 2. So 1/2 radius squared times the sine of the pizza slice angle, 72, right? So whatever that is. Now, again, I don't feel like doing like 50,000 things. So I still have this 3.4 number stored in my calculator. I'm just going to square that first. Then I'm going to divide it by 2. Then I'm going to multiply by that sine. Okay, so for one triangle, I end up with this number. That's for one triangle, but I need 5 triangles, right? So I'm just going to multiply by 5. And I end up with 27 point something. It keeps on going. I want to round to the nearest square inch. So I'm going to look at where the whole number ends. Look at that 5, right? 5 means we round up. So my final answer here is 28 square inches. All right, so to review what we do. First things first, find your radius. What is the radius? I need this thing I labeled X over here, right? It's either going to be using cosine or sine. So take the time to draw this out and figure out whether or not you're working with cosine or sine. All right, make sure that you know how to use this. Then write your equation, solve for the radius, figure out what it is, and then you're back to where you started. Square the radius, divide by 2, multiply by the sine of the pizza slice angle. There's your triangle. How many triangles are there? Multiply by that much, and then you're done.